Hi everyone, welcome to Deep Learning Talks. So we were talking about bidirectional encoder representation of transformers, which is BERT. We noted in the last video, we noted that it is bidirectional. We noted that it is a transformer. We noted that it is an encoder only transformer. There is no idea of causal masking, and there is masked language modeling. So it is BERT is used to produce richer, more expressive embeddings, right? GPT also produces embeddings. What are these embeddings, right? So when we say BERT embeddings or GPT embeddings, we usually mean the hidden states that have been produced by the transformer. We don't really confuse with the token embedding matrices. In case of GPT embeddings, those embeddings have inherent causal masking. What do I mean by that? All of these embeddings are causal. How they are causal? Because they have been produced where GPT only knows the tokens to its left. In case of BERT embeddings, all of the BERT embeddings are bidirectional. What do I mean by bidirectional? BERT can see left to right, BERT can also see right to left, BERT can see the future, BERT can see the past, BERT can see the surrounding context, right? So each token embedding is contextualized using both left and right context, right? So it is obviously not, the embeddings are not causal in nature. Now, if we try to think about the use cases, let's say the GPT embeddings are great for text generation. They are, since GPT is very much generative in nature, so since it is generative, we can also say that it can do autoregressive generation. It can also do autocomplete generation. It can also do story continuation. It can also simulate like a conversational chatbot. Whereas if we talk about BERT, how would we use BERT? How would we fuse in the BERT embeddings? We can fuse in the BERT embeddings for search. We can fuse in the BERT embeddings for semantic similarity, where we want to produce embeddings and maybe measure the similarity on a semantic level to see how semantically similar are two tokens or are two sentences or are two documents, right? We can use it for classification. We can use it for question answering. Why? Because see, their BERT might not be generative in nature, but all of the BERT embeddings, they represent meaning. They might not represent the sentence continuation or an autoregressive generation, but they represent something known as meaning. Why? Because BERT has always been trained to do fill in the blanks based on the surrounding context, which is nothing but masked language modeling. That's how BERT has a little different use cases, whereas GPT has little different use cases. Now, some more questions to answer. So, what GPT is optimizing for? GPT is trained using causal language modeling, the idea of language modeling, the idea of next token generation. So, we use something like a cross entropy loss function, right? So, GPT maximizes the likelihood of the next token, and the conditional probability is given the previous token. What is the maximum likelihood? What is the likelihood of the next token? Right. So we talked about maximum likelihood estimation in detail in case of logistic regression. And cross entropy, I think it's one of the OG loss functions which is used at a lot of places, especially where we want to do k-set classification. So we know that GPT uses cross entropy loss. It maximizes the likelihood of the next token given all the previous and the current token. Now the loss is computed at every position in the sequence, and every token tries to guess the next token given the previous sentence or given the previous tokens. But now the second question is this objective function, is this loss function good for BERT? I don't think so. Why? Because BERT is obviously bidirectional. As the name suggests, BERT does not works on the objective of next token prediction. BERT is not generative in nature. BERT is not auto-regressively generating tokens. In case of BERT, every token is allowed to see the future and see the past. What I mean by see the future and see the past is BERT can go left to right, BERT can go right to left, and we don't mask the future tokens. We do random masking. We do mask the tokens randomly. We do mask language modeling, but we don't mask all the future tokens. So if we ask BERT to predict the next token, it would already be able to see it. So we can also call it cheating. I mean, mathematically, we can prove that it cheated, and we can also call it cheating. We the training has the training phase has seen all the future tokens, and when at inference part we use it to predict the next token, I don't think so it would work out the way we envision it to. So the main thing is what BERT is actually optimizing. What is the core that BERT is actually trained on? So BERT is trained on not causal masking, not causal language modeling, but on masked language modeling. What we actually mean by that mathematically is BERT also uses maximum likelihood estimation. BERT maximizes the likelihood of the masked tokens, of the randomly masked tokens. For example, let's say we masked 10 to 20% of the tokens. BERT maximizes the likelihood of the randomly masked tokens given all the unmasked tokens, right? So given all the surrounding context of unmasked tokens, BERT randomly maximizes the likelihood. So The follow-up question is, do we still use cross entropy? Obviously, yes. We still use cross entropy, but we use it a little differently, not exactly same with the same objective as we did in GPT-2. The difference is where we use cross entropy and how we apply it as compared to GPT-2. In case of GPT, we saw the whole GPT family cross entropy loss is computed for every token position. But in case of BERT, we know that cross entropy is used only for the mass tokens. Okay. So my closing notes on GPT and BERT would be, so GPT is basically solving, given all the past, what is coming next in an autoregressive way, in a continuation way, so that I can keep on writing and keep on simulating whatever I've seen as the text. But what is BERT solving? Given the entire sentence with some missing words, what should those missing words be? What should I place in those missing words? BERT is learning a contextual understanding. BERT is a contextual understanding model. GPT is learning a sequence continuation. GPT is a sequence continuation and a sequence generation model. So the last closing notes, if we were thinking about conditional probability, if we were thinking about both these models in terms of conditional probability, GPT says basically, what is the probability of token xt given x1, x2, x3, x4, so on, xt minus 1? Whereas, what is BERT doing? What is the probability of xi given x of context for randomly sampled tokens or for randomly selected tokens or positions? I think that's it for BERT and GPT. So we now have an opinion on encoder only transformers and decoder only transformers, and we know their objective and their training style, their masking style, and their inferencing style, right? So I think we can close BERT and GPT safely now. Thank you for listening. I hope it was helpful for you.